All right. So we just finished writing rational numbers as decimals. So now we're going to go to ordering rational numbers. So the first bullet point I'm going to have you write down is that you change all numbers to decimals to compare. And then think about it. Can you compare an apple to an orange? Well, you can say that they're both fruit, but you can't say which one is better, right? You need to actually be comparing the same thing in order to say which is better. So it's the same with numbers. I need to have them all in the same form so I can figure out which is greater, which is lesser. And so that's what the first bullet point's saying. It's saying change all of the different forms of rational numbers into decimals to compare them. And then after you compare them, the next rule is write in original form when ordering. And I'm going to underline original form. So let's give you an example. I'm going to compare negative 1.4 to negative 8/5 to 0.6 to negative 0.9 to 1/4. Okay, 3 of those numbers are already in decimal form. So there's only 2 I have to convert. I have to convert the negative 8/5 and the 1/4. So let's start with the negative 8/5. I've got negative 8/5. I'm going to turn that into my long division. I'm going to pull down the 8, right? I'm going to put a decimal point and some 0 placeholders in. I'm going to throw that decimal point up into my top answer. How many times does 5 go into 8? Once, right? And that gives me 5. I'm subtracting with 3 left over. 5 can't go into 3, so I'm going to bring that first 0 down. Now I have 30. How many times does 5 go into 30? 6. Good. So therefore, I've got a positive 5 and a negative 8, right? So my answer then is negative 1.6. And then let's do the 1/4 underneath it. And I've got 1/4, which I'm going to turn into long division. I'm going to bring the 1 down. 4 can't go into 1, so I'm going to put a decimal point and 2 0 placeholders. I'll pull the decimal point up to the top. How many times can 4 go into 10? 2, right? And that gives me an 8. If I subtract 8 from 10, I get 2 left over. I'm going to carry that 0 down. How many times can 4 go into 20? 5 times. Perfect. The 1 and the 4 are both positive numbers. So if you look on the wall for the rules for integer operations, when you multiply and divide, when you have the same sign, what kind of answer do you have? Good. So the answer here is 0.25. So now I'm going to rewrite it. Whoa, flying pens. So what I've got is a negative 1.4. We said that the negative 8/5 comes out to a negative 1.6. Then I had 0.6. Then I had negative 0.9. And we said 1/4 comes out to 0.25. So now I'm going to draw a number line. And in the middle, I'm going to put a 0. This is my negative side, right? Down here, my negative side. And this is my positive side. So all my negative numbers are going to be to the left of the 0. And all my positive numbers are going to be to the right of the 0. Now, what do you remember about negative numbers? The further away they get from 0, do they get less in value, right? Yeah, they're worth less. So if we're going to order these from least to greatest, which negative number is going to go at the end? Is it going to be negative 1.4 or negative 1.6? It is. It's going to be negative 1.6. So I'll say negative 1.6. I'll just make that right there. So then the next number coming in is what? Getting closer to 0. Yeah, so my next one is negative 1.4. I only have one more negative number left. What is it? Yep, so I'm going to put that here, and that's going to be negative 0.9. So now let's go to the positive numbers. On the positive side of the number line, the further away they get from 0, do they get bigger or smaller? Bigger, they're worth more. So which one's going to go closer to the 0? The 0.6? Hold on, think about it. Why do we use zeros as placeholders in math? What are they worth? Exactly. So let's take that 0.6 and throw a 0 on the end. And then we've got 0.25. So now we're comparing two numbers with two spaces after the decimal, two numbers after the decimal. Which one is bigger, 0.60 or 0.25? 0.60. Right, because it's 60, not 25. So our first one is going to be 0.25. And then our last one is going to be 0.60. So now we have our original numbers all converted into decimals and ordered on a number line from least to greatest. So I could rewrite that now as numbers in their original form. So the negative 1.6 was actually the negative 8/5, right? The second number we have was the negative 1.4. After that, we had negative 0.9. Then we have 0.25, which was originally represented as 1/4. And then we have 0.6, which was originally 0.6. And I would box that out because that would be my final answer.